Okay, the next two numbers, that goes up by 4, so does that, so does that, so go up 4, 18, and then go up another 4, 22, that's 1 done. And now on to 2. Okay, next two numbers of the sequence, it goes up by 2, and then it goes up by 4, and now it goes up by 8. Okay, so it's doubling each time. So this one here is going to go up by 16. So that'll be 16 plus 17, that'll be 32, 33. And now it's going to go up by 32, because it doubles each time. 32, that'll be 65. And that's 2 done. And now on to question 3. Okay, you can find a number bigger than 1, which is both a square and a triangle number. Well, we know the square numbers. This one's 1, 4, 9, 16. Triangle numbers, well, they make triangles. The first one actually is 1. Second one is that, 3. The next one, you add 3 more dots underneath that, and that'll be 6. And the next one will have that 6. And then add 4 dots underneath. That makes a triangle. That's 10. So each time here, that goes up by 2, then it goes up by 3, and then it goes up by 4. The next one will go up by 5. And we're trying to identify a square number. 15. None of those are square numbers yet. Plus 6, 21. No good. Plus 7, 28. No good. Plus 8, 36. Yep, 36 is a square number. It's 6 times 6. We've identified it. The answer is 36. And that's 3 done. And now on to question 4. Okay, find a number bigger than 1, which is both a square and a cubic number. The reason why it says bigger than 1, because 1 is a square number, and it's also a cube number, because a cube number means 1 times 1 times 1. The next cube number will be 2 times 2 times 2, which is 4 times 2, which is 8. That's not a square number. The square number is 1, 4, 9. Next one will be 3 times 3 times 3. That's 27 times by 3. That's 9 by times by 3, it's just 27. The next one will be 4 times 4 times 4, which is 16, it's 64. And 64 is a square number, because 8 times 8 is 64. And so we have it. We found a number. 64 is the answer to that. And that's 4 done. And now on to question 5. So we write down the first 5 terms with a sequence where that's our rule. So the first term will be when n equals 1. The second term will be when n equals 2. The third term will be when n equals 3. Fourth term when n equals 4. And the fifth term will be when n equals 5. So our rule is n minus 2. So the first time n will be 1. I've got to do 1 minus 2, which is negative 1. The next one, n's 2. So I'll have to do n, which is 2, take away 2, which is 0. So that's minus 1, 0. The next time I'll have to do n, which is 3, take away 2, and that it gives us 1. The next will be 4, take away 2, which is 2. That's the next one. And then finally, the last one will be 5, take away 2, which equals 3. And those are the first terms, the one I've underlined. And that's 5 done. And now on to 6. Okay, which one doesn't fit 6? I'm going to write them out again so I've got more space. 1, 3, 6, 11, 15, 21, 28. Let's see what they go up by. Up by 2, up by 3, up by 5, up by 4, up by 6, and then up by 7. It's here. It's there. If that wasn't 11, if that were to be 10, then it would have gone up by 4, and then it would have gone up by 5. So the 11 doesn't fit. Does not fit. It would if it was 10, but there we are. Actually, these are triangle numbers, aren't they? 1, 3, 6, and the next one would be 10, like so. But they put 11, so they made it like that. It's not a triangle. 6 done. And now on to question 7. Okay, Lear states the rule for sequences 3n's plus 1. Let's try it. 3, 4, 5, 6. Well, each time it goes up by 1 each time. So therefore the rule must be times by 1. So it'll be 1 times n, which is just n. And so for n, the first term when n is 1, 1 times n is just 1. How do I get to 3? I add 2. Let's just check first, second, third. So we've got this term here, n equals 3. So we do 3 plus 2 makes 5. That's right. It should be n plus 2. But she said 3n plus 1. So I'm afraid she's wrong. And that's 7 done. And now on to question 8. Something like this. It might be worthwhile writing each one directly under the other one. So 3, 6, 9, 12. And under there 5, 8, 11, 14. As soon as that, the eye hasn't got to wander so far, you can actually see that each time here, then we've added 2 to each term of the sequence. And so let's do it in red. What are the rules for the first one? That goes up by 3. That goes up by 3 as well. And that goes up by 3 as well. So it must be 3 n's. Let's just see what I've got. First term n is 1. 3 ones are 3. Well, that's what I want to be. So first term is 3 n's. The one under here, that also, obviously they go up by 3 each time. So that means it must be 3 n's. And we've added 2 to it. So it's going to be 3 n's plus 2. Just check. 3 ones are 3. How do I get to 5? I add 2. That's the way it works. That's 8 done. And now on to question 9. Okay, the third and sixth terms of a linear sequence. So linear means it goes up by the same amount each time. So we've got 15 and 27. So we've got the first term, second, third, fourth, fifth, and sixth. And the third term is 15. And the sixth term is 27. So it's got to go up by something, and it's got to go up by something, and it's got to go up by something, and it's got to be the same amount each time. And so those 3 steps, and they must make from 15 to 27 goes up by 12. Therefore, each one is plus 4. So plus 4 would take us to 19. Plus 4 would take us to 23. It's often worthwhile just checking it works. Plus 4 takes us to 27. So I work out the first term, so I need to go back this way. So I'm adding 4, so we take away 4, which gives me 11, and then take away 4, that'll give me 7. So the answer is 7. That's 9 done. And now on to question 10. Sequence starts at 1, so we've got 1. And then it continues by multiplying the previous term by a number. So I've got to multiply it by something and then subtract 2 each time. And that takes me to 3. I've got to work out the next 2 terms of the sequence. So what do I have to do? I don't want to have to multiply by. But I know that when I subtract 2 from it, I get 3. So it must have been 5. So that is going to have to mean I have to multiply it by 5 and then take away 2. Just check. 1 times 5 is 5. Take away 2 is 3. That's good. So I now know what the rule is. It's times 5, take away 2. So that'll be 15, take away 2 is 13. And I need to times that by 5 and then take away 2. 5 13, so it'll be 50, and 5 3 is 15. That's 65, take away 2, 63. And that's 10 done. And now onto the extension. Okay, so we've got complement fill up with hexagonal tables connected together like this. So we need a rule, don't we? So I'm just going to get started off. I'm not going to do the whole of the extension. So tables, we've got 1 table, we've got 2 tables, we've got 3 tables. So how many chairs? And so chairs is going to be 6 for the first one. Then I've got 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. So I've got 10 there. And this one here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Got 14. And now I can see what's happening. It's going up by 4 each time. So I need a rule for that one. It goes up by 4 each time. So it's definitely going to be something to do with 4 n's, where n's are a number of tables. Let's just try n equals 1. 4 ones are 4. How do I get 6? I add 2. So that does the first bit. And we're going to set up an equation. So 4n's plus 2, that is the number of tables, number of chairs, equals number of chairs, and n is the number of tables. So you do 4 times the number of tables and add 2, we get number of chairs. So 4n plus 2, how many tables will we need for 50 chairs? So 4n plus 2 is the number of chairs, so that equals 50, and then you can work out how many tables and just check it's right. But I'll leave it at this stage, and that's the whole of this work on sequences done.